Hello and welcome to another episode of our podcast Power On. My name is Christian Schaider and I will be your host today. Transformer aging has become an increasingly issue with many units operating well beyond the intended lifespan. As the energy landscape evolves with the rise of renewables, these assets face new challenges with heavier or less predictable loads. Midlife Refurbishment, which focuses clearly on extending the operational lifetime of power transformers through targeted measures like condition assessment, upgrade of components, has become a clear strategy for maintaining grid reliability. Today we are joined by Mr. Marc Foata, technical expert in the field of asset management solutions and a long-standing member at CIGRÉ, where he has contributed significantly to shape and change our industry. Marc, it's a personal pleasure to have you here today. Welcome.
Yeah, nice to be here. Thanks for the nice introduction.
Marc, can you start by telling us about your role at CIGRÉ and CIGRÉ's agenda on the midlife refurbishment topic?
Well, CIGRÉ is organized in 16 study committees. One of these sub-study committee is for power transformers and reactors. This is a group of about 80 members coming from all over the world, from all affiliation. We have consultant, OEMs, of course, utilities, manufacturers. And the chair of this study committee is Pascal Müller, and I am the secretary. So we are the two officials, and the role of the study committee is to share knowledge. This is the main mission of CIGRÉ: share the knowledge, develop the knowledge and share it for the benefit of the worldwide community. And in doing this, the main product of the study committee are technical guides. Mm-hmm. There's, of course, conference and the session.
The one in Paris, yeah.
The one in Paris is well known, and also that's the one in Paris is every even year, and every odd year we have the A2 colloquium. The next one will be in Korea in October.
Oh, okay.
Yeah. We also organize webinars and tutorials. So really it's bringing the community together, sharing. So it's very interesting to have the experience from all over the world, different practices, different contexts, different situations. So that's very beneficial. So that's the role of CIGRÉ. Midlife refurbishment is about reliability and sustainability. And these are continuous topic for CIGRÉ. So there's not been specific activities on midlife refurbishment, but we've had multiple brochures in the past on reliability, for example, and more recently, this reliability survey has been updated, was released just last year. We had also a very important technical guide that was published about 2 years ago. It's called Life Extension of Power Transformer.
The paper 887, right? Yeah.
Yes. We also have, this is more current issue, a life cycle assessment. So this is about CO2 emission. And this may have a very big impact on the strategies, because if you factor in the cost of CO2 emission in your analysis, you may find that refurbishing compared to replacement is more cost effective. So that's roughly what my involvement in CIGRÉ is and the current activities.
It's very interesting. Brings me to my next question. So what are the primary challenges for asset managers when they plan for a midlife refurbishment? You mentioned, okay, logically we have the technical conclusion. Now we have to think about the CO2 emissions. Is there any other challenges?
Well, I would say the biggest challenge, if you can picture this situation, this is a very common situation. You are a transformer operator and you have a number of units. They're about 35, 40 years old. They're still running fine. They show some degradation normal, but they're still running fine. This is what you said in the introduction. In many cases, the book life or the financial life of the asset of a transformer can be 40 years. And then the situation is that after these 40 years, this asset has no more book value, but it's still running fine. And the question is, what should you do about it?
Correct, yeah.
Then there's the do nothing option. I mean, it's running fine. You have typically this kind of questions. What happens if we don't do anything next year? well, probably nothing will happen, right?
Yeah.
So you're in this, let's say, comfortable position, and you have to look at the other alternative. What about if we reinvest? Now, the question is, reinvesting on something that is running fine is a challenge. And for that, you need to build a business case, look at the two options, replace versus refurbishment. And you have to look at different scenario and to build a business case and to convince your stakeholder, yes, it makes sense to reinvest in this asset today when it's still running fine.
I think about risk evaluation. I for sure have assets in the fleet where I have a very proper and good documentation. Maybe I have less information. Load is changing with the rise of renewables. Unpredictable loads is also, I think, a very huge topic. So how would you or CIGRÉ in that paper approach this risk evaluation?
Yeah, that's the most difficult question to evaluate the risk, especially how the failure rate will evolve on this aging unit. So for this, CIGRÉ, I just mentioned earlier, has released recently a new survey on the reliability of transformers. And this is an update from a previous survey that was done 10 years ago. And what is interesting in this new version is that they didn't look only at the failure rate, they also looked at the replacement rate.
So when they put the asset into retirement, replaced it with a new
Exactly.
unit, yeah?
When a decision is made, okay, this asset is old for different reason. In some countries, for example, the regulator will require that after the initial life, 40 years, for example, is completed, you need to replace. This was the situation when we were working on this guide for life extension. We went to Brazil during the WorkSpot conference, and then we organized a workshop. So the idea was very interactive. We had the crowd of about 100 participants coming mostly from Brazil and South America.
Mm-hmm.
And we were asking questions of, okay, what are your practice for life extension? And we had very funny answer, unexpected answer.
Unexpected, okay.
And at the end of the workshop, they came to us and they said, look, in Brazil, the regulator says after 40 years, you need to replace the asset. So we're not doing life extension. But this, I found out recently, is changing because they realized, okay, there's so much value left in the assets.
No more book value, but still in a technical good condition where you could
technical value, exactly.
Think about it to do something. Okay.
Yeah, exactly. So this is changing. So that's one reason to plan for a replacement. But in most cases, the difficult question is to evaluate how the risk will evolve. So this working group on reliability, they have really investigated how the failure rate will increase over time. And most interesting result was that if you have let's say, aggressive replacement strategy, you will not see the failure rate increased with age, because what you're doing is actually retiring the units that you feel are less reliable. Maybe in some cases they were about to fail, and you take them out of the statistics. So the reliability, the failure rate looks good. But actually, if you want to have the real failure rate, you would need to find a utility which has a run to failure policy. Now the statistics are a bit biased. So I'm just trying to say that it makes the evaluation of the failure probability even more complicated, because you need to factor also what are the replacement policies of
the different strategy play also. Oh, it's very interesting.
But I think the CIGRÉ is very helpful in that regard. And the solution we recommend, and this is also in the guide on life extension, is to have scenarios. You have to make let's say, an average scenario, and you have to make let's say, optimistic and pessimistic scenario, just to encompass all sorts of possibility. And on that, after that, you need to factor in your company tolerance to risk.
This is a very good point. So which methods are most reliable? So I need different scenarios for assessing possible scenarios. You mentioned then the individual organizations. How would they evaluate for them the best cost-effective scenario for such an refurbishment in comparison to a replacement scenario?
You have to do what is called a life cycle costing analysis. And in this, you will compare different scenarios. So let's take a simple example, a replacement today or in the near future versus a life extension. Then the first thing you need to do is to establish what is the time period that you're going to consider. So in this case, typically probably 30 years, the next 30 years. And then you need to factor all the costs in the future. So some costs are easy. I mean, if you buy a new unit today, you know what the cost is, purchasing, installation, and so on. And this is today's cost. If you consider life extension, what you're going to do is you're not going to invest so much on the new unit. You're going to invest less on the refurbishment work. And then this will delay the investment to a full unit, a brand new unit later in the future. And then you need to compare also, for example, the maintenance cost. For the two scenario, you need to factor the losses. Electrical losses can be an important factor. More recently, you need to factor the life cycle assessment, the CO2 emission. So we've seen that some utilities are putting a penalty on life cycle assessment. Yes, load losses and also manufacturing and so on. And this additional factor is another incentive to look for midlife refurbishment. So you do a complete life cycle costing analysis, look at all the future costs, use the net present value of these, bring everything to today. And of course, the best solution is the one with the highest net present value. So that's the standard way to do this analysis. But it's not easy.
It's not easy, obviously. So it's also not only technical driven, not only indirect, it's cost driven, clear, but the cost driven factor comes also with the CO2 emissions, which plays obviously nowadays a bigger and bigger role also for utilities when they consider that more and more.
It's coming more and more. Yeah, we see that. And there's not just the A2 study committee or study committee incentive. There's also other study committee are really looking at life cycle assessment. So this is a major activity these days in CIGRÉ.
You mentioned it now already, life cycle assessment. So when I'm thinking about when to do it, to find the best time window, because I wouldn't do anything when the asset is still running fine. When I'm too late, then for sure it's something possible, but maybe already the degradation is moving onwards, that my planned measures are not that effective as they would be when I would do it 5 years earlier or something like this. How I find out the best time window, or where is a critical time window for such a midlife refurbishment?
Well, again, it's a life cycle costing analysis. So you can consider different possibilities, doing it now or in 5 years and 10 years, and look at the sensitivity of the result. So the issue here is most components, if we're talking about a network application, a transformer, which is probably loaded less than 50% because of a N-1 contingency requirements. What is the experience is that after 40 years, the solid insulation condition is much better. There's still a lot of residual life in this. However, the components are aging faster.
Outside, you have the bushings, you have the environment situation.
The tap changer might also be aging, depending motor drive or the controls, the preservation system, the gaskets. This is something that is quite often overlooked, but leaks are a major issue in aging. So the idea is you try to maximize the use of the components with respect to the lifetime of the transformer. And to do this, I mean, if you want to use a maximum the reliable life of all these components, is to do it at least once. Again, not too early, because then you're not really improving the reliability. And if you do it too late, what happens is that the degradation might be so advanced that it's too costly. And then you have less time because you're not extending the life by so much. You have less time for your return on your investment. The experience from utilities is that they're doing this between the age of 35 to 45 years. But that's for, again, network application, where the insulation will typically outlast the components. And they estimate a life extension of about 30 years.
So additional 30 years.
Yes, additional of like almost as new, reliable transformer, an additional 30 years of reliable operation.
Double it.
Yeah. So a few example I have in mind. One policy from a utility in Europe is do it at 45 years and extending the life by 30 years. So that brings the transformer to 75 years.
Wow, that's very long. Yeah,
was not in anybody's mind if you go back 20 years ago. So 35 to 45 years. And when you do, and there's some example of that in the brochure on life extension, calculation of when is the best time to do midlife refurbishment. And this is confirmed by this analysis.
However, each transformer is a little bit different. I have maybe the typical network transformer. However, even in the network, I have maybe an indoor application, outdoor application, different load levels. Here in Germany, the utilities back in the day, for sure, below 50. Nowadays, some critical transformers face even more load, 80, 100% loaded. So what would be the best to find out? Is the gasket damaged now? For sure, the bushing is fine. But you mentioned especially gaskets are overlooked. Would it be like to do a condition assessment at a regular interval to have a proper, also for the management, and I think for insurance cases, that would be for sure also helpful to see, okay, nothing going on, all good. But in the future, I should look more closely on the bushings. There's a trend going on or so. And there's maybe monitoring nowadays also very helpful. Do you see there is a practice already?
Oh, yeah, clearly. I mean, there's a standard practice. I mean, there's also CIGRÉ has been involved in this, is to do what we call a condition assessment and to develop the so-called health indices. It's standard practice, but I have to say almost every utility have their own methods. And this was very clear when the working group was trying to establish this health index. We had meetings where there was about 30 people involved around the table, and everybody had their own recipe. So what the conclusion was that there's no good or better health index. You develop your own, and if it suits your purpose, perfect. So this guide actually does not recommend a single health index or what we call condition index, but methods and different criteria to do it. I think this is important to understand that also, and I like what Tony McGrail from Doble said about this, is that condition or health indices are not meant to be perfectly accurate. They are meant to be useful. So every utility is using a health index to rank their fleet. And then you have different factors that are weighted, but leaks should be a factor, condition of the insulation, reliability of the components. You can imagine all sorts of factors.
CO2 nowadays.
CO2 could be a factor, exactly. So, and you may have a condition index for replacement ranking, for what we call fit for purpose. So the unit may be running fine at normal load, but cannot be overloaded, for example.
So maybe when I expect heavier load, I could theoretically move the asset.
Target this unit. Yeah. Another utility has developed a spare unit index.
Oh, okay.
Looking at their spare units and what condition they are for and ready to be used in case of a failure.
Yeah, the spare assets is always nice to have this N-1 strategy, but when I overlook the condition of my spare transformer and when I need it, it's also...
Yeah, their experience was that there were surprises because you think this transformer is ready to be installed and you find out, you go to the yard and find out that they already took some parts for doing maintenance. So this was very useful to know the condition of their spare transformers.
It's a good standard, but first moment you don't think about it. No? You have it and you feel safe. Personally, you worked also back in the day for a big utility. Which challenges have you experienced personally back in the day were most challenging for you when you plan for a condition assessment or for a midlife refurbishment strategy?
Well, the biggest challenge we had was we had to present our risk analysis to the regulator. And this was some years ago already. So was the start of all this was the challenge to really establish how the risk will be today, and not only today, but what will be the risk in 10 years if we do this, for example, strategy or this other strategy. this is when we also developed our own condition index and tried to be as accurate as possible. And in the end, be convincing to the regulator, which is a representative of the public. There you have all sorts of people on this board. So this was a challenge. Try to be convincing and have a solid approach and the best we could do. At the time, we were not compliant. I mean, the ISO 55000 was not really implemented. There was the British version, the original version, PAS 55. And we're not compliant, but nowadays, a lot of these bigger utilities are compliant, and then you have to be very, very structured and organized in your approach.
When you left the utilities already a few decades ago.
Yeah. But the challenge was the condition assessment and the risk analysis, like it is still today.
Yeah, but everybody's doing it. No? This is what I'm hearing out. No? Everybody is looking on the condition of the assets, however, a little bit individually. And through the work of CIGRÉ, you learn and see different approaches, unexpected answers. You said one is looking more on this, the other is looking more on the replacement strategy. The next one consider also the backup transformers and so on.
Another factor I would say is the company policy, investment policy. In some utilities, you can have a replacement of bushing, for example, on your CapEx budget. In some utilities, if you cannot reinvest on an old asset. And there's all sorts of rules, which are accounting rules that can be changed. But this is a factor that needs to be considered when you look at different scenarios. And for my utility in the past, there were some discussion and some challenge to modify these rules.
To even theoretically move costs, which are maybe OPEX.
Yeah, exactly.
To move it to CapEx costs. So it can also help companies to be flexible with the costing structure.
Yes, that's the idea. Well, sometimes it's rigid, but if you have some flexibility, that can really be a factor in your midlife refurbishment scenario.
My last question, looking ahead, obviously nobody knows what is coming, but I think it always an interesting question. What key initiatives has CIGRÉ on the agenda when we look ahead? You mentioned the CO2 emissions. Is there something going on?
Yeah, the CO2 emission. We have also, of course, like everybody else, looking at the digitalization. Okay, all these methods, machine learning, artificial intelligence. The idea is if we can improve our aging models, again.
Digital twin.
Yeah, digital twins. When you do asset management and when you present your asset management strategy, it's not just for today. It's also make sure that your strategy will be valid over the next 5 to 10 years so that what you're saying you're doing, you can achieve also not today, but
has an impact for the future as well.
So another initiative is data sharing. A lot of utilities are collecting their data. Of course, data has value. Data can be sensitive. But if every utility keep data for themselves, we're losing a great opportunity because, the larger volume of data, the more we can do with analytics and these digital twin and so on. So this is very new, and we're trying to create a platform, neutral platform using CIGRÉ, where the data could be anonymized and shared and create a large pool of data for research and would be available for everyone for the benefit of everyone. So this is quite challenging in terms of legal aspects, also value. But this is something we'll be working on and hopefully will be successful. Yeah, digital twin, life cycle assessment, materials, of course, materials, but it's the scope of another study committee, but we're working close together with study committee D1.
Very interesting what the future will bring. Marc, thank you very much for giving all these insights, especially also what you're doing at CIGRÉ. I'm sure our audience will have fun with this episode. I say thank you for watching and listening, and goodbye.